Hello, good morning. I just wanted to continue the lecture on the moon and see if we can get through taking our notes. So let me start with the lecture title and lecture. Our moon, I believe it's lecture number 2. And what we're doing here is just basically trying to understand the background and a little bit of our lunar features. So understanding our satellite background and features. First of all, a couple of things on basic information. Basic info. The moon is our only satellite. Diameter of the moon is approximately 3,475 kilometers. That's the moon. Compared to the Earth, which is approximately 12,756 kilometers. That's the Earth. If you remember, in terms of size comparison, about 4 times, but the distance is about 400,000 kilometers. So if we were to draw the moon, the Earth would be about 4 times its size. I'm just going to estimate the bottom of the Earth. And the distance between these two bodies is about 400,000 kilometers. If you remember, in terms of some of the astronomy understanding and conceptions, you can fit about 30 Earths between the Earth and the moon. So it's a pretty long distance. 400,000 kilometers is a reasonable distance. In terms of the exploration of the moon, we learned about 6 Apollo missions. From 1969 through 1972. 1969 is important because it fulfilled John Kennedy's promise that we will get to the moon and bring man safely back to Earth within the decade. He said that in the early 60s. So we were able to achieve that by 1969. Lots of things happened in the United States at that time, as we were in the Cold War and basically competing with the Russians. The Apollo missions that made it to the moon is Apollo 11, 12, 14, 15, 16, and 17. 13, of course, made it to the moon but never actually landed on the moon. These are 3-man missions. You'll find out about that a little bit more later on. But 2 land on the moon, and then 1 remains orbiting around the moon until they complete the mission and then come back after exploration. The age of the moon. Remember, one of the things that the moon can give us is a little bit of an insight into the formation of our own planet and the solar system itself. So the age of the moon is about 4.3 billion years old. The average density first of all, let me give you of Earth. Of Earth is 5.5. The moon density is 3.3, which approaches the Earth's mantle. the Earth's mantle. Gosh, can't write this morning, sorry. Now, why is the difference between 5.5 and 3.3? Remember, density is mass over volume. Is basically what's speculated is the moon has a smaller iron core, a small iron core. Okay, and then lastly we'll wrap it up with the structure in this side, and in the structure itself I'm going to draw an iron core, an outer core around the inner core, and then the crust itself. So let's label it. That's the inner core. That's the outer core. That's the mantle. And that's the crust, which is what we see in terms of the cratering of the moon and stuff like that. We're looking at the crust. Okay, so I'm going to continue in the back to be able to give you some of the surface features, the lunar surface features, and then we'll wrap up this lecture. So in the back, continuing, you can pause this at any time if it's going too fast for you. Again, please forgive my handwriting. Sometimes it works, sometimes it doesn't so much. Okay, so let's talk about the lunar surface. Okay, first of all, it's full of craters. It's pretty obvious when we looked at it, and the observations that you've done confirm that. Full of craters and Maria. Spelled Maria, but it's pronounced Maria. And the singular for Maria is Mare. The singular is Mare. So in the maps, as you've seen in your structures, there's a lot of mares that you can see. Some of the largest structures are identified as seas. There is no atmosphere. That should have some serious implications when you think about the formation of the moon itself and why its surface looks like it does. No atmosphere. And there is no surface water. No surface, my goodness, no surface water. We actually have been able to find out that there is near the caps, the polar caps of the moon, if you will, a little bit of water in form of ice buried, and they actually crashed a probe into it to be able to detect it, and they have, but there is no surface water. Craters, let's talk about craters a little bit. And they're produced by impact meteorites. At the beginning of the exploration of the moon, there was a belief that maybe they were volcanic completely in origin, but the majority are impact meteorites. So the components of it are a rim. Let's draw an oval figure, and on the side would be accumulation of debris called ejecta. Let's see, you can kind of, and then on the side, what they call rays. In the middle, the crater itself, there is such a thing as a crater wall, and it's sometimes structures in the middle, like protruding mountains, rock formations and stuff. So let's label it. This is called ejecta. This is the raised rim. This is the floor. and these are called rays. There's a whole study of geomorphology. It would be actually moon morphology, looking at the forms and what they imply. The issue of that was discussed heavily before the Apollo missions ended up landing on the moon is trying to decide what spots they were going to land, centered exactly around the issue of whether these were volcanic or whether created by impact meteorites. There's some peculiarities about some of the way they form. They all seem to have perfectly rounded, the majority are perfectly rounded, but not all of them. And so at first they look like volcanoes, but they're not. Next one, we're going to talk about highlands. And they're mountain ranges. Mountain ranges over a large percentage of moon. One comment on this is on the side, please make a comment on the highlands, lighter colored rocks. Okay, lighter color rocks. The Maria are beds of basaltic rock. They're beds of basaltic rock flows from asteroid impact. Then Riles. Oh, one comment on the Maria, again on the side. Maria, because of the basalt color, they are darker color rocks, which allows us to see the Maria easily, even with the naked eye. Darker colored rocks. So easily discernible two types of rocks that we can observe. Now don't forget that our famous, keep an eye on this, ojo. That's important to be able to remember this part. Now, again, you can stop it at any time to be able to catch up if I'm either moving too fast or don't quite have the paper lined up. Riles. They're distinct valleys or trenches. Now, they kind of look like this. And these would be ancient lava flow channels. Ancient lava flow channels. Next is regolith, and we're pretty close to wrapped up. Regolith. They're lunar soil, approximately 3 meters thick in some areas. Lunar soil, approximately 3 meters thick. Now, question to leave you with in the portion at the bottom. Okay, you can you can catch up, stop, we'll make sure about the question at the end is for you to ponder. First of all, why is our surface, by that I mean the Earth, so different than the moon? The second one is, can you think, why is the surface of the Earth so different than the Moon? And can you think about origins? Think about the origin of the Moon. How, why, etc. Okay, with that, thank you very much.